This is our Stats 2120 final project by Anna, Kaylee, Mary, and Van.
We got an Excel document with data from Dr. Met's Fall 2023 and Spring 2024 Stats 2120 class. The data included 19 variables: semester, gender, faces, year at Elon, whether it was a first-year exclusive class, random, and score, rank, version, and time for test 1, 2, and 3.
For our first research question, we decided to find if there was a correlation between time spent testing and score earned. For this, we decided to use a PROC-SG plot, and we did it for every single test. The X value was the test time, and the Y value was the test grade.
After we ran our SAS code for a PROC-SG plot, we received these three scatter plots, where our x-axis is time and our y-axis is grade. Each scatter plot corresponds to a different test, and as you can see, there is no specific linear pattern, which is showing that there's not an association between the two variables. Is there a correlation between time spent testing and score earned?
No! Our scatter plots were not linear, which suggests no correlation between the variables time and score. One possible limitation in this finding is that often students vary in testing needs, and some take more time than others despite their level of knowledge in the class.
For our second research question, we asked, does the mean test score increase over the duration of the class? We used the PROC means to compare the means between the three test scores. We used VAR to compare the numerical scores of test 1 grade, test 2 grade, and test 3 grade.
These were our results for question 2. This is our output table, and it's important to notice that the number of students in test 1 was higher than all the others. Our means were 71.97, 73.93, and 79.82.
Does this mean test score increase over the duration of the class?
Yes. The mean earned score for test 1 was 71.97, for test 2 it was 73.93, and for test 3 it was 79.81. These values mark a steady increase over the course of the class. However, one possible ramification in our data is that some data points were missing, and so the data wasn't necessarily fully comprehensive. Also, as noted in the previous slide, there were more marked observations for test 1 than any of the other tests. For our third research question, we wanted to investigate if there was a correlation between gender and grade. In order to explore this, we needed to use a PROC core. However, PROC core can only be used with numeric variables, and gender was categorical. So, we had to convert gender into a numeric variable. In order to do this, we used the code right here, where we set our project and gave a new project name, and then we said if gender equals F, then gender numeric would be 0. Same thing for if gender equals M, then gender numeric would equal 1. And then when we ran that code, it converted gender into a numeric variable. Then we used a PROC-SG plot to gather a visual representation of the data as well. So not only do we have our PROC core here, where we have our numeric variables as the test 1 grade, test 2 grade, and test 3 grade, with our new numeric variable of gender, we also have our PROC-SG plot using VBox to get box plots using test 1 grade and category, and we ran this for test 2 and test 3.
Mary ran the code. Here is our core procedure. The table on the bottom shows each p-value and correlation. With correlation, the closer the values are to 0, the weaker they are. For test 1, the correlation was negative 0.04853, which is weak. For test 2, it was negative 0.14280, which is also weak. For test 3, it was negative 0.09576. This indicates that it was also weak. A weak correlation indicates no association between gender and grade. The numbers below our correlation are our p-values. The first p-value was 0.5622. Our second p-value was 0.0998. And our final p-value was 0.72711. All of these values were greater than alpha, which is equal to 0.05, which was our tested level of significance.
These are our results for question 3. We used ProcSG using VBox to create our box plots for each test. Looking at our box plots, you'll see that our x-axis is for gender. Make note that there is a third gender, non-binary. Our y-axis is the test score. We ran this code for all 3 tests. If you look at these box plots, the center line indicates mean. On average, the mean score was higher than male and female.
Let's conclude question 3. Is there a correlation between gender and grade?
No, there's not. The correlation between test 1 grade and gender was negative 0.04583. This is weak, negative, and does not show an association between grade and gender. The p-value was 0.5622, which is large and greater than alpha, which is 0.05 and a level of significance. The correlation between test 2 grade and gender was negative 0.14280, which is also weak, negative, and doesn't show an association. The p-value was also large and greater than alpha. Similarly, the correlation between test 3 grade and gender was also weak and negative, with no association being showed. It was negative 0.09576. The p-value of p equals 0.2711 was also large and greater than alpha. However, we do have a limitation in our data, which is that not every student's gender was accounted for. Yes, the average mean for non-scores was higher on each test, but the difference between male, non, and female was not significant enough.
Let's summarize what we found. There is no correlation between time spent testing and the grade earned. Mean grade earned on tests did increase over time. There is no correlation between gender and grade. If we could have designed the data collection, we would have tried to have fully comprehensive data with no missing values, equal amounts of observation across all 3 tests, and possibly another semester's data to give us more comparison values.